On an ordinary day over Jezero crater, a camera on Mars captured something it was never meant to see. A thin pulse of light cut across the frame as if the universe had accidentally revealed a secret. At first glance, it looked like nothing, but the more you stare, the more wrong it feels. Because that streak did not match dust. It did not match cosmic rays. It did not match anything Mars orbiters usually record. And yet, almost no one talked about it. The silence around that image is louder than the image itself. 3. I Atlas. The third confirmed interstellar object ever found by humans drifted past Mars at the exact moment multiple orbiters were watching. It was the closest any interstellar visitor had ever come to being photographed in detail, and somehow the world missed it. You are about to understand why what those cameras captured does not fit neatly into the boxes we use to explain comets. It hints at behavior that scientists have quietly debated behind closed doors, and the parts that reached the public were softened, filtered, and stripped of context. If a single frame from Mars can bend the rules this much, imagine what the unreleased frames look like. 3. I Atlas did not enter our solar system the way ordinary comets do. It arrived fast with a trajectory sharp enough to reveal its origin before astronomers even finished their first calculations. The moment its path was mapped, the pattern was unmistakable. It carried the same interstellar signature once seen in Oumuamua, and later in Borisov, the first two visitors ever confirmed. As it moved deeper into the inner system, something rare unfolded. Instead of being observed only from Earth, the object slipped into a perfect alignment that made Mars the closest major platform to watch it. Between the 1st and 7th of October 2025, the Trace Gas Orbiter and Mars Express locked their instruments onto the passing traveler, capturing images from roughly 30 million kilometers away, a vantage point no ground-based telescope on Earth could match at that moment. For the first time in human history, an interstellar object passed close enough to another planet for us to observe it from the side of the solar system, rather than head-on from Earth. It opened a new observational window, a chance to see how these ancient wanderers behave before the sun heats them and turns them into something else. And this is where the real question begins. If this encounter was so rare and scientifically valuable, then why did the world hear almost nothing about the images Mars captured? NASA had announced that images from the Mars orbiters would be released to the public, but the timing could not have been worse. A federal government shutdown froze non-essential communication and outreach, which meant the images of an interstellar visitor passing near Mars were stuck in a queue, with nobody allowed to publish them. Days passed, then a week, then more. By the time the shutdown lifted, the spark of global curiosity had already faded. What finally emerged were a handful of frames from the Mars Reconnaissance Orbiter taken on the 2nd of October using the HiRISE camera. They showed 3I Atlas as a dim point of light, barely rising above the noise of deep space. The release was quiet, almost muted, as if it had slipped out unnoticed, during a storm of unrelated headlines. Many journalists described the delay as unfortunate, but harmless, yet within the scientific community, the reaction was different. Several researchers pointed out that the shutdown conveniently created a vacuum in the news cycle, a silence that prevented real-time discussion and peer analysis. Instead of a global conversation about the closest interstellar pass ever, image the event dissolved into scattered blog mentions and small astronomy forums. And this is where the story stops. Being simple. If nothing about the encounter was controversial, then why did it feel as if the information had been slowed, softened, and allowed to evaporate before reaching the public? What exactly was missing from these images that no article bothered to mention? While the world barely noticed the delayed Mars images, something far more important was happening behind the scenes. The James Webb Space Telescope turned its mirrors toward 3I Atlas and recorded something completely unexpected. Inside the comet's coma, the telescope detected an unusually high concentration of carbon dioxide. The ratio of carbon dioxide to water reached about 8:1, which is far higher than anything seen in most comets from our solar system. A composition like this does not happen by accident. It hints at a birthplace in an environment colder, darker, and more ancient than any region near the Sun. At the same time, the transiting exoplanet survey satellite quietly gathered its own data. Tests revealed that 3I Atlas had already been active at a staggering distance of roughly 6.4 astronomical units long before solar heat should have been strong enough to wake it. That kind of early activity breaks the rules. Comets are not supposed to behave like that. Together, these clues point to a material recipe unlike anything formed in our planetary neighborhood. It is a chemical fingerprint from a different star, a relic from the early epochs of the Milky Way, a time so old that the Sun itself had not yet ignited. And yet, none of this made headlines. None of it appeared in the news summaries that focused on a few blurry Mars images. If you think the story ends with pretty pictures, hold on, because the truth hidden behind the data runs much deeper than what the public was shown. The images captured from Mars might look simple at first glance, but their rarity makes them priceless. Multiple spacecraft were watching 3I Atlas from different angles. The Maven orbiter recorded fluctuations in the surrounding space environment. The Mars Reconnaissance Orbiter used its high-rise camera to catch the interstellar visitor from about 0.2 astronomical units away, roughly 30 million kilometers. Even the Perseverance rover caught glimpses of the object as it drifted across the thin Martian sky. These are perspectives we cannot obtain from Earth. But those views came with a cost. None of these instruments were designed to track a fast-moving interstellar comet. The light was weak, the motion was rapid, and long exposure times turned many frames into noisy streaks that engineers had to fight to salvage. This is why so few images exist. This is why every usable frame is treated like a scientific treasure. They offer the closest real look humanity has ever had at an object born outside the solar system and untouched by our sun's heat. And yet, despite how precious these data are, many of the observations remained overshadowed, forgotten, or simply never discussed. Which raises a question that cannot be ignored. If the images are this rare and this valuable, then why were some of them left out of the conversation? What exactly was hiding between the frames that never reached the public? The strange quiet surrounding 3I Atlas did not come from science alone. Part of it was political. When the federal government shut down, NASA's public communication channels were restricted and non-essential releases were frozen. The images from Mars fell straight into that silence. By the time the shutdown ended, the story had already slipped through the cracks of the news cycle. But politics was only the surface. The technical issues were just as heavy. The early images were noisy and difficult to interpret, which led several experts, including Avi Loeb, to criticize the release. He argued that the frames were too degraded to reveal anything meaningful, and that the public was being shown only the most convenient slices of the data. That comment ignited a quiet storm. Because behind the scenes, more scientists were whispering the same thing. They wondered whether the object behaved too strangely to be dismissed as a simple comet. And if that were true, then the lack of communication from major institutions felt even more suspicious. This is the point in the story where the questions stop being gentle. When silence appears exactly where clarity should be, you are forced to ask what that silence is protecting. And that brings us to one of the biggest questions in this entire investigation. What exactly is this object? Interstellar objects are not just passing debris. They are time capsules from places our sun will never reach. 3. I-Atlas carries within its material the chemical fingerprints of a star system that existed long before Earth formed. Observations from Mars and from distant telescopes allow scientists to compare its makeup with the comets native to our solar system, and the differences are striking enough to challenge long-held models of how icy bodies evolve. These clues hint at a story written in the earliest eras of the Milky Way, an age when the galaxy was younger and wilder and filled with violent star-forming events. Every grain of dust inside 3i Atlas is a message from that forgotten time. And yet the world barely heard about it. That is the real irony. When the news falls, silent science continues to speak through the data. You and every viewer watching this are witnessing the quiet moment before a shift in our understanding. But the discovery does not stop here. There is still a hidden layer of the story that few have talked about, and it changes everything. While NASA's delayed release made the story feel incomplete, another twist unfolded on the other side of the world. China's Tianwen-1 orbiter captured images of 3i Atlas between the 1st and 4th of October and released them before NASA could publish its own. For many researchers, it felt like a rare moment in which another nation briefly overtook the usual flow of scientific headlines. At the same time, amateur astronomers on Earth recorded stunning images of the object, including a now famous capture where 3-1 Atlas drifted in front of the galaxy NGC 4691. In those images, the comet displayed multiple tails, including an ion tail and an anti-tail, a phenomenon the mainstream press barely mentioned. But the most profound detail came from chemical models. Several studies suggested that 3's Atlas may belong to the thick disk of the Milky Way, a population of ancient objects formed 9 to 13 billion years ago, long before our sun existed. If that is true, then this is not just a comet. It is a survivor from a different era of the galaxy carrying materials that formed under conditions no longer found anywhere near us. And this is where many scientists grow silent. Because if an object this old and this unusual does not follow the rules, then we must ask what else is hiding behind its behavior. If it is not entirely natural, then what is it? We have followed this story from the quiet moment over Mars, to the delayed data, to the hidden clues scattered across research papers and forgotten telescope logs. 3. I-Atlas is not simply another comet drifting through the inner system. It is a message from beyond the solar neighborhood, a relic from a place older than Earth and older than the sun itself. The silence around it does not erase its importance. It only makes the questions louder. This is why curiosity matters. This is why skepticism is healthy. Stay curious. Stay critical. And if you want to follow where this investigation leads next, I invite you to subscribe and turn on notifications, because the next chapter explores something far more unsettling. What happens when this interstellar visitor continues its path, and whether it leaves a measurable trace behind. Before we go there, ask yourself one thing. Are you ready to hear the whole story? Because in the next video, we will reveal the internal structure map of 3i Atlas based on data that has never been shown in public. You will not want to miss it.